Hey, good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at question 8 for the November 2024 question paper. All right. So we know that question 8, it is filled with counting principle. Sorry, not counting principle, first principle rather, as well as the derivative rules, right? Yes, but here I do not see any counting the first principle. How unfortunate of them. Okay, now we have 8.1.1 that says, okay, 8.1 says determine what exactly 8.1.1, the derivative of the function with respect to x. So d dx, okay, so I'm going to derive d with respect to x. So this one, it is already simplified. I just need to say, okay, therefore the answer will now be, remember when you are given the notation d dx, it is the same as this notation, okay, just dx. So every time when you are given this notation, check whether everything here, is it ready to be differentiated now? Is it ready to be derived now? But you can see it is fine. There is no, remember, we cannot differentiate when there is what? A square root of x or x as the denominator or whatever that you are differentiating with respect to. So in this case, everything is fine. We just say equal sign, and then you just write the derivative of 3x. Remember, it is a special case. It is 3. And then the derivative of 5x squared, it is 2 times 5. 2 times negative 5, it is negative 10. Then x squared minus 1, it is just x. So this is just your answer. Do not put d dx, it is equal to, no, it is wrong. Your answer is just this. Okay, yes. On this one, 8.1.2 says determine the derivative of g, okay, or g prime, okay, if g of x, it is equal to 2 divided by x squared minus cube root of x to the power of 7. Now remember, we cannot differentiate if whatever that you are differentiating with respect to. What are we differentiating with respect to? We are differentiating with respect to x, right? So x cannot be at the denominator. It can also not be inside a radical, whether it's square root or a cube root. So what should I do? The first thing I should do, it is fix g of x before I can derive. Fix g of x. How can I fix g of x? I take this x squared, take it to the top. When I take it to the top, the x squared is going to be rather negative x to the power of negative 2 minus, how can I move this cube root of 7 to the power of x to the power of 7 inside the cube root like that? Remember when I have, let me say minus, remember when I have n, remember this is square root, so it's going to be, let me say a to the power of n b. It's going to be a to the power of n divided by b. Okay, I just remove the square root and then divide by exponent by whatever that is here. Let's look at the actual number. Let's say I have okay, x to the power of 4 cube root. So it's going to be just x to the power of 4 divided by 3. Remember, those are the exponents like that. So that's basically that. So can I do that here? Definitely. How can I do that? I'm going to say it is x to the power of 7 divided by what? By 3. Can we see that? Beautiful, isn't it? And then, am I in a position of deriving? Yes. Why? How is that so? I do not have any x at the denominator. I do not have any x inside the square root or a radical. So am I in a position of deriving? Yes. When you derive, you need to say, I'm now deriving. You need to show us that you are now deriving. Okay. Do not derive here before. You should make sure that your equation, it is in the standard nice form before you can derive. And then negative 2 multiplied by 2, it is negative 4x. And then negative 2 minus 1, it is negative 3. Please use your calculator if you're not confident. And then 7 divided by 3 multiplied by negative 1 here. It is just negative 7 divided by 3x. And then 7 divided by 3 minus 1 here. It's the same as saying minus this divided by this. It's going to be 4 divided by 3. So that's basically that. Easy, isn't it? So just easy. Moving this from a square root, the denominator, a mark for removing the radical thereof for a cube root, and then differentiating this, differentiating that. This one is just a mark. Guys, these are easy marks. Okay, These are easy marks that one should be in a position of getting in an equation paper. 8.2 says determine the equation of a tangent to this graph. Okay, to this graph at a x it is equal to 2. So how do I find an equation of a tangent to a graph? Remember, if I'm having a graph, this one, it is a cubic, right? So this one is a cubic graph like this. And then somewhere there, I'm having a what? A tangent, okay? At this specific point where x it is equal to 2. I don't know the y. I'll just say it is y for now. All right? This is the graph of f. This is my tangent. Now, they are telling me that determine the equation of a tangent at this point. At this point where they are in contact, what do we know about that point? At this point there, let me just call that point P. At point P, let me do this. At point P, what happens? The derivative of the function, okay, the gradient, okay, let me say the gradient of the tangent, it is equal to the what? To the gradient of the function, okay, at a specific point. Remember when I get the gradient of f, how do I get the gradient of f? Remember when I derive f, I get its gradient, right? Remember the derivative, it is the gradient. So when I derive f, I get the gradient, right? But now at which x coordinate? So this, okay, let me explain this. This derivative of f, it is just a gradient of the whole function, okay? It is the gradient of the whole function. But I want to find a gradient at this specific point. I need to know exactly the specific x coordinate here. In this case, I know. What is the x coordinate thereof? The x coordinate in here, it is 2. So at x it is equal to 2. The gradient of the function at this point, it is going to be equal to the gradient of the tangent at that point. Okay, this the derivative of f is just the gradient of the whole function, meaning you will get a function that looks more like this. Can you see? It is of the whole function. But now we want at this specific x coordinate, okay, where x is equal to 2. And then we're going to say it means now the gradient of the tangent is equal to the derivative of f. Okay, the gradient of f at x it is equal to 2. Then we can find that. How can we find that? We can find that by saying, let me find the derivative of x first. How can I derive x first? It's going to be 3x squared. When I derive this, right? It's going to be 3x squared minus 2 times 8, 4, so it is 8x plus 2. Again, plus 2. But I know that the gradient of the tangent, it is equal to the gradient of the function at x is equal to 2, which in actual fact it is 3 into 2 squared minus 8 into 2 plus 2, and then it gives us the gradient to be something like 3 times 4, it is 12 minus 16 plus 2, I don't know, negative 2. So this is the gradient of a tangent, right? This is the gradient of a what? Of this tangent here. This tangent here. Another thing I forgot to mention is that at point P, they share the coordinate. They share the what? The x and y coordinate. So here it is the point of contact. They share that coordinate. So if I want to find y, remember, for me to find the equation, I need y is equal to, okay, let me say y minus y1 is equal to m into x minus x1. I need the y value. I already have the x value, right? To be 2. Okay, to be 2. So how can I find the y value? For me to find the y value, I can substitute into the equation of the what? Of the cubic function. Why? Because it is also a point on that graph. Can you see? It lies on that graph. So I'm going to just find a, let me do this. I'm going to just find f of 2. Why am I saying f of 2? I want the value of y on this equation when x it is equal to 2. The point here, basically. So I need to say f of 2, which it is equal to now 2 cubed minus 4 into 2 squared plus 2 into 2 plus 3. how much do I get in actual fact? I get 8 minus 16 plus 4 plus 3. And then I have negative 8 plus 4, it is negative 4. Negative 4 plus 1, it is 1. So I get 1. So I can say now, therefore the equation of a tangent, it is y minus y1 m into x minus x1, where y minus y1, it is equal to, I think it's negative 1. Let me repeat up. It's 8 minus 16 plus 4 plus 3. This is negative 8. Negative 8 plus 4, it is negative 4. Negative 4 plus 1, yeah. So it's going to be y minus into minus 1. So it's just y plus 1. Gradient, negative 2. Gradient of the tangent, negative 2. X minus, what is the x coordinate thereof? It is 2, right? And then I can do my mathematics. It is negative 2x. Negative 2 multiplied by negative 2, it is positive 4. Positive 4 and then minus 1. This one is going to be just 3. This is basically that, guys. You needed to understand the first thing, that the derivative. Sometimes you get that you have this part, and then you have a gradient like this. So it's still the same thing, basically, guys. So yeah, hopefully you understood. Just need to try to sketch that, just a sketch so that you can pick up some few points that at this point P, they share the coordinates. They also do what? They also have the common tangent. Sorry, the common gradient at a specific point where x it is equal to 2. Hopefully that's clear, guys. I can move on now. Let me erase this quickly. And then when I move on to 8.3, which is now inverse functions, inverse functions and the derivative are not the same. So we are given 8.3, given this one, f of x is equal to negative x squared. Determine f prime x from the first. I was amazed, how is it possible that there is no question, this question? So how can I determine this? This should be fairly beautiful for us to do. It should be fairly beautiful. Let me say, okay, I have f of x, it is equal to negative 6x squared. What do I want? I want the the derivative from the first principle, right? We know that normally this question, it is somewhere here on the first one, but hey, that's fine as long as we have it. So what do I like to do first? Remember, I will use this formula at the end. Limit as h approaches 0 of f of x plus h minus f of x divided by h. So what I can automatically get, it is what? F of x plus h. This is what I like to do and tell my students to do so that their mathematics becomes easier. So I have negative 6 into x plus h. This one tells you where you see x, just put a bracket and substitute it with x plus h, right? X plus h all squared. And then when I simplify that, it turns out to be something like negative 6 into x squared plus 2xh, x times h times 2, 2xh plus h squared. And then when I try to simplify that, let me just write the final answer. I think you already know how to do that. Okay. Hopefully I did not make any mistake. Now, this is what I like to tell my students to do. How do you expect your final answer to be here? When you derive this, you expect your final answer to be 2 multiplied by negative 6, negative 12x. This is your final answer. You're expecting this. So, yes. And then after getting f of x plus h, what do I want to do? I want to get, I check my formula still has f of x plus h minus f of x. So I want to go to my formula when I just only substitute. So let me get f of x plus h minus f of x. Okay, then what is f of x plus h? It is negative 6x squared minus 12xh plus h squared minus what? What is f of x? F of x, it is negative 6x squared. Okay, so, and what I tell my students, again, you're going to forgive me, I always tell my students this, is that either way, you are one of the students if you're watching this. If you reach this point where you have f of x plus h minus f of x, when subtracting these two functions there, something with an x squared should not appear. Okay, when you are subtracting here, something with an x squared x squared should not appear. When x squared appears, so it means there's something wrong that you did. Okay, only when you're saying f of x plus h minus f of x, that's where it should not appear. So can you see that when I say this one is the same as saying plus, because negative by negative, right? So negative 6x squared plus 6x squared. Do you agree? Do you agree with me that negative 6x squared plus 6x squared will now cancel off? And then when that happens, I'm gonna be left with what? I'm gonna be left with negative 12xh plus h squared. I hope that makes sense. And then what? And then I'm done. I can now move and say, I want my first derivative, okay? Remember, my first derivative has a formula that says limit as h approaches zero. Very, very important. As h approaches zero of what? Of f of x plus h. Write down the formula minus f of x, all divided by what? By h. And then I can now be in a position of substituting very beautifully. What is f of x? Remember, you cannot leave the limit until the final step where you substitute. Okay, what is f of x plus h minus f of x? Can you see that we have already found that? We have already found that here. So it will just be, what is the outcome? It will just be negative x h. Can you see that we actually made things easier for us? Negative 12xh plus h squared. And then let me just come here. All divided by what? By h. Remember, what is my goal? My goal is to remove this h at the denominator. Why is that the case? Because when I were to substitute h as 0 here, I cannot get the exact value. It will be undefined, okay? You normally say maths error, yeah, but you get undefined. You cannot divide by 0, okay? So you cannot have any constant divided by 0, but you can have 0 divided by constant, which is 0. But in this case, this one is not possible. It is undefined, okay? So what is my goal? It is to remove this h. How can I remove this h? I just need to take what h as a common factor. Only h, not negative h, guys. Just take out h as a common factor. Never mind the negatives, okay? Just take out h as a common factor. When I take h as a common factor in here, negative 12xh divided by h is going to be just negative 12x plus h squared divided by h, it will be just h. And then divided by what? By h. And then can you see that the h now cancels the h thereof? I don't like showing cancelling because sometimes you remove answers, guys. And then it means my f of x, the derivative of f with respect to x when h approaches 0 is going to be just negative 12x plus h. Am I now in a position of substituting h as 0? Yes. Why? Because there's nothing that can distract me from doing that. Oh, okay. Then if that's the case, let's see. When I do that, I'm going to get f prime of x, it is equal to, remember when I'm substituting, I no longer write the limit. So it is negative 12x plus 0. Can you see in actual fact it is just negative 12x? Is it correct now? According to our thing here, yes, it is correct. We were expecting that answer thereof. Remember, find f of x plus h first, and then find the difference between f of x plus h minus f of x. When you are done, you can now be in a position of going to your what? Your equation. It's fine. You can do it manually, usually. Okay, you can do it in here. Write this formula and then do your calculations thereof. It's fine, but it is much easier for you to spot the mistakes when you're doing it this way. Either way, just take the method that will work out for you. Okay, that will work out for you. Okay. Let me quickly erase that so that we'll move on. What do they say to us now here? They are saying, let me clear the page. Done. 8.3.2 rather says, write down how you will restrict the domain of f such that remember f negative 1 is the inverse. The inverse of f is such a function. Remember when you derive, okay, Remember when I'm having a cubic function, okay, so not a cubic function, a parabola like this, remember it is negative. When I derive, okay, I think them putting this and the derivative is going to be confusing. When I find the inverse of this one, the inverse of this one will be something more or less like this. Okay, so this will be the inverse. But now the inverse of f, remember this is f and this is -1. How the inverse of f is not a function. Why? Because when I take my vertical line test, okay, and put a vertical line test anywhere on the inverse, can you see that it touches my graph how many times? 2 times. So remember, if my vertical line test touches my graph more than once, it is not a vertical line test. So it is not a function. So now the question is, how can we restrict this such that it becomes an inverse? Remember, I have a video where I have explained how to restrict the domain of the inverse of a parabola such that it becomes an inverse. Please look out for that. So it's either you say x should be greater or equal to 0, or x should be less or equal to 0. So these are the two things. How, when you do that, remember we had a function like this of the inverse. When you do that, you are saying, I only want this part, or I only want this part. Can you see? When you only want this portion thereof, by doing that, can you see it now fits the vertical line test? It touches once. And then also on this one, it touches once. So please look out for that video. It's going to help you a lot. And then they say determine the equation of the inverse for the inverse is less or equal to 0. I'm going to tell you why they are saying this here. Okay? I'm going to show you. Now, let me write f of x here. What's the first step of finding the inverse? Remember, let me write this as y. You remember the first step, you swap x and y. When I do that, I get x, it is equal to -6y squared. And then after swapping x and y, number 2, you solve for what? For y. How do I solve for y? I solve for y by saying I need to divide by -6. It's going to be x divided by -6. It will just be 1 divided by 6x, or let me not confuse you, like this. Okay, it is equal to y squared. And then I need to take a square root on both sides. When I take a square root on both sides, what happens? When I take a square root on both sides, I get that y it is equal to what? Square root of negative x divided by 6. X divided by 6. Guys, remember one thing. When you take out a square root, like square root of, okay, when you root that, take out the square root, the answer will be plus or minus 2. So also here we need to say equal sign, plus or minus, okay, square root of -6 divided by x. But now they told us that y should be less than, sorry, the inverse, rather. The inverse should be, remember this is the inverse that we have found here. They are telling us the inverse should be less or equal to 0. So meaning our inverse should be negative. Okay, should be negative. So it's either it is positive or negative. I've explained how we can choose on the video under inverse. I won't go through that again. So they are telling us that the inverse should be negative. So we're gonna say therefore y it is equal to negative. We are choosing now x like this divided by 6. Now what I want you to take note of is that the x here, there is a restriction about the x. Remember, x cannot be equal to 0. Ne? Okay, it can equal to 0. Actually, I'm lying. X can be equal to 0. But remember, a square root cannot be negative. Okay? Cannot be negative. So, how can we avoid this? Remember, now I'm having negative x divided by 6. How can I make this one positive? Because if I were to put x as 1, it's going to be -1 divided by 6. So how can I do this? I need the value of x to be negative, whatever value of x that I put here to be negative, guys. Very, very important. The value of x that I need here, I need it to be negative. Why? So that when I say negative into negative 1 divided by 6, can you see negative and negative is going to result to positive 1 divided by 6, so that I can get an answer. Okay, so what do I need? I need the value of x. This is the restriction, very important. I need the value of x to be less than 0, x or equal to 0. When x is equal to 0, check, it's just 0 divided, negative 0 divided by 6, which is just square root of 0 is equal to 0. Okay, but now, if I were to let x to be equal to 6 rather, it's positive, right? Check what happens. It's going to be negative 6 divided by 6, which is negative square root of negative 1. And square root of negative 1, it is just I, and we haven't done that yet. So for you, for now, it's not undefined. But what if I put a negative 6? What if I put a negative 6 instead? When I put a negative 6, it's going to be negative by negative. It's going to be 6 divided by 6, which is now what? Square root of 1, which is equal to 1. So my restriction says the value of x, whichever value of x that I input, it's either it is negative, less than 0 means negative, or it should equal to 0. Then this should be your final answer, guys, for that question there of. Hopefully I explained. And then they tell you write your answer in the form of y. Okay, so yeah, it is already in the form of y. So thank you guys for joining me. Hopefully you enjoyed. So yeah, let's move on to question 9 under the very same question paper, guys. It's gonna be interesting and nice. So yeah, hopefully this one wasn't that challenging. Okay, yeah, thank you.